Hello, welcome to Chapter 7, Homework Questions 47 through 52. Question 47. The leadership class at Mount Heron High School is organizing a shoe drive. A local business has agreed to donate boxes to collect the shoes in. If each box can hold 20 pairs of shoes, draw a step graph relating the number of shoes collected to the number of boxes needed for up to 200 pairs of shoes. So we need to label our X and Y axis. The X-axis would represent the pairs of shoes, and then the Y-axis is going to represent the number of boxes. Okay, and then we also need to set up our intervals as well. The number of shoes, pairs of shoes, has to go up to 200. So we'll figure that out here in a second. And then the number of boxes needs to, if there's 20 pairs in a box, so it looks like we'll need to go up to at least 10 to show that. So let's go ahead and label those. Alright, so I labeled the X and Y axes, and then now we start creating our step graph. So for 0 pairs of shoes, we're going to need 0 boxes. So that's kind of where we start. But then once we get 1 pair of shoes, anything from 1 to 20 will fit in 1 box. So anything from 1 pair up to 20 pairs of shoes will be in the first box. And I have the open circle at 0 because if we have 0 pairs, it's going to be 0 boxes. And then at 20 pairs of shoes, once you get to 21 pairs, that's going to move up to 2 boxes. When you get to 40 pairs, or 41 pairs actually, it's going to move up to 3 boxes. And then this just continues, and you see the step function that is occurring. And so once I'm done, I went all the way up to 200 pairs of shoes. You can see that 200 pairs of shoes will need 10 boxes. And if you go over that, though, then you're going to need 11 boxes. So that represents the step function or the step graph that we're looking at. Question 48. Assume that a DVD loses 60% of its value every year it is in a video store. Suppose the initial value of the DVD was $80. We have 5 questions we're looking to answer. What multiplier would you use to calculate the video's new values? So to maybe give you a better idea as to what that multiplier would be if you don't see it right away, is I kind of created a table here so you could see what was happening. So the initial value is 80. The first year it loses 60% of its value. So when you lose 60% of your value, you're starting at 100% and you're losing 60%. So you're only going to be left with 40% of that value. And so at year 1 it would be $32 because I am multiplying 80 times the 40%. That's what that value is. So the multiplier for A is 0.4. And we could put the 0 on there if we wanted to, but not necessary. But that's 40%. What is the value of the DVD after 1 year, after 4 years? So you can see I already figured it out after 1 year by multiplying by 0.4. So after 1 year, it's $32. And then after 4 years, I can keep doing this to figure out what year 2, 3, and 4 will be. And so completing the rest of the table by multiplying by 0.4 each time, I got a value on the 4th year of $2.05 for the 4th year. Part C, write a continuous function v of t to model the value of a DVD after t years. So I used x and y, but we can easily change this. This would represent t, and this is v of t. And so we're going to write a continuous function to model that. So v of t, because this is exponential, our initial value is 80 times our multiplier 0.4 raised to the t power for the number of years that we will be trying to find the value of the DVD. Part D, when does the video have no value? Well, according to this model, it never will. But in reality, a DVD would have no value if it breaks or if there's no longer, something to play it or, whatever, or just over time no one's going to want to buy it. So we can keep multiplying by 0.4 over and over again, and it'll get really close to 0, but we'll never get to that 0 value. Now, in terms of money, because, eventually if we're round to the nearest cent, it would get down to 0 that way, though. So just for fun, I went ahead and plugged this into my calculator, and I went and looked at the table, and at year 11, you get 0.003. So even though that's not 0, money-wise, if we rounded that, it would have a value of 0. So even though, once again, according to the model, that value would never get to 0 all the way across, we could say in year 11 that it would lose its value completely. Part E, sketch a graph for this function. Be sure to scale and label the axes. So I just went ahead and labeled the axes, put the scales on there, and you can see that we are decreasing. Our multiplier is less than 1, so the value is decreasing. Once again, it'll get close to that value of 0, but technically would never get there. And we have that horizontal asymptote right there at y equals 0 as well. Question 49. This problem is a checkpoint for solving problems by writing equations. It will be referred to as checkpoint 7a. For each problem, write 1 or 2 equations to represent the situation and then solve. Be sure to define your variables and clearly answer the questions. So we have 4 different ones here, so this might take a little time to get through all 4 of these, but once again, you're either trying to set up a system of equations, which is 2 equations, or if you can set up 1 equation and 1 unknown, that is fine too. Okay, and then you're going to solve those for each of the 4. So on part A, the Lees have 3 children. The oldest is twice as old as the youngest. The middle child is 5 years older than the youngest. If the sum of the ages is 57, how old is each child? Well, the oldest is twice as old as the youngest, and the middle is 5 years older than the youngest. So it sounds like we need to have our let statement, let y equal the age of the youngest child. Okay, and so if we know that, then we know the oldest child. So I'm just going to say the oldest here. In terms of the youngest is twice as old as the youngest, so that's 2 times y. And then we know the middle one is 5 years older than the youngest, so that would be 5 years older would be y plus 5. And so we have the age of the youngest, the middle, and the oldest. So if we know that the sum of the ages is 57, how old is each child? Well, we can just take the values of the youngest plus the oldest plus the middle and add those up to be 57. And so we can combine our like terms, which would be 4y, subtract the 5 to the other side would be 52, and then take 52 and divide it by 4 to get 13. So the youngest child is 13. The oldest is 2 times 13, so that's 26. And then the middle is 13 plus 5, and that would be 18. So how old is each child? We have a 13-year-old, an 18-year-old, and a 26-year-old. And make sure you answer that question, as you can see I did on the bottom there. All right, let's look at B. In Katie's garden, there are 105 ladybugs. They are increasing at 2 ladybugs per month. There are currently 175 aphids, and the number of aphids is decreasing at 3 aphids per month. When will the number of ladybugs and aphids in Katie's garden be the same? All right, so looking back, Katie's garden, there are 105 ladybugs. They are increasing at 2 ladybugs per month. So we know one of our variables needs to be let m equal the number of months. And then as it goes along, the last sentence says, when will the number of ladybugs and aphids in Katie's garden be the same? So we're going to let another variable y equal the number of insects. So that'll just depend on which one we're talking about. And so therefore, we're going to have two equations. We're going to look at the ladybugs, and so we have 105 plus they're growing or increasing 2 ladybugs per month, so 2 every month, and that will equal the total number of ladybugs. And then we have 175 aphids, and the number of them are decreasing, so you're subtracting 3 every month, and that will equal the total number of aphids at the end of that time frame as well. The question is, when will they be the same, though? So when in Katie's garden will they be the same? So since they're both y equals, we can set these expressions up so that they're equal to each other. And then solve. So I'm going to add 3m. I'm going to subtract 105. And then divide by 5, and we will get m equals 14 months. So it's going to take 14 months for the ladybugs and aphids to be the same in Katie's garden. And so once again, make sure you do answer that question completely. On to C. At the farmer's market, Laura bought 3 pounds of heirloom tomatoes. If the tomatoes are priced at $8 for 5 pounds, what did Laura pay for her tomatoes? So this one, she had bought 3 pounds of tomatoes, and they tell you what the price is. So we know how many pounds she bought. We know what the price is per pound. What did she pay for her tomatoes? So we're just going to say that we want let x equal the amount paid. Okay. And then we can go through here, and if she bought 3 pounds of tomatoes, then, and if the tomatoes are priced at $8 for 5 pounds, so we don't know what they cost per pound. I think I said that wrong originally, but we know that she's paying $8 for 5 pounds. So we can set up a proportion here, I think. If we say we want to do pounds over the cost, then we can say 5 pounds cost $8, and 3 pounds right here cost what? And that's what we don't know. So we can solve this proportion to figure out how much 3 pounds cost. So we can multiply both sides by 8. That will cancel this side and give us 5 equals 24x. Then we can multiply both sides by x to get rid of the denominator on the right side. And then divide by 5. 24 divided by 5 is $4.80. And so therefore Laura paid $4.80 for 3 pounds of tomatoes. That's 3 and then LBS for pounds. Alright, so now we are on to the last example. D. Adult tickets for the school play cost $5. Student tickets cost $3. 30 more student tickets were sold than adult tickets. If $1,770 was collected, how many of each type of ticket was sold? So how many of each type of ticket was sold? There's 2 types of tickets, so we're going to set up two equations and 2 unknowns for this one. So D, we're going to say let A equal the number of adult tickets, not the cost. We know what the cost is. So the number of adult tickets. And then we're also going to have let, what's the other one? Student tickets. I don't want to use S, so I'm just going to use T. Let T equal the number of student tickets. Okay? And so now we can write our 2 equations. We know the tickets cost $5 for an adult, $3 for a student. And we also know that $1,770 was collected. So we can say that for $5 for an adult ticket plus $3 for a student ticket is equal to $1,770. But we also know 30 more student tickets were sold than adult tickets. So 30 more student tickets were sold than adult tickets. So we can say that the number of student tickets is equal to the number of adult tickets plus 30. Since there's going to be 30 more student tickets, we can say that there's 30 plus the number of adult tickets. And so now you can see the setup there, and it's a system of equations, and you can solve using elimination or substitution. This one is set up for substitution, so that's what I'm going to go ahead and use. I'm going to substitute the, let's go back there, substitute the expression t equals a plus 30 into the t value. And so let's see what we get. 5a plus 3 times a plus 30 is equal to 1,770. We're going to need to distribute. Combine our like terms, subtract the 90. And then divide by 8. So a is equal to 210. So that's the number of adult tickets. And now we can find the number of student tickets by saying that the student tickets is equal to the adult tickets plus 30. So therefore the number of student tickets is 240. So we know there's 210 adult tickets and 240 student tickets sold. And just as always, make sure you answer the question. So that is a checkpoint dealing with setting up, taking an application, being able to set it up and solve it. Question 50. Multiply and simplify each expression below. On part A, you have a binomial squared. It is important that you expand this out. So if it's x minus 3 quantity squared, then it's x minus 3 times x minus 3. So when you go to simplify this, you get x squared minus 3x plus 9. And so sometimes we make the mistake of thinking this is x squared plus 9, but when you expand it out, you do see that you do have a middle term there, and it's not just canceling out. Also remember, this is where you can use your generic rectangle and say x minus 3 and x minus 3. As always, you still get the same values as when you use the distributive property, but in the end, this right here represents the simplified version of those two being multiplied together. Part B, same thing. 2m plus 1 times 2m plus 1. So when you distribute, you get 4m squared plus 2m plus 2m plus 1. 1 times 1 is 1. And then 4m squared plus 4m plus 1. And as I said before, you can still use the generic rectangle on this one as well. On part C, you'll notice that you have three things that you're multiplying by. So you have an x minus 3, and an x plus 1. Well, you can't multiply three things together at once. You have to do two at a time. So it's up to you on how you want to do this. What two do you want to multiply first? I'm going to go ahead and multiply the two binomials first. So x squared plus x minus 3x minus 3. And then I'm going to simplify. So that's x squared minus 2x minus 3. And then now on the last part, all I have to do is take x and distribute it into all three terms. So x squared times x to the first. Remember, you add the exponents, it's x to the third. Minus 2x squared. Once again, you add the exponents. And then minus 3x. And then the last one, part D, we have a binomial times a binomial, but you'll notice it's a little different than the ones from A and B because you have a squared term in one of your binomials, but it works the same way. 2y times y squared is 2y cubed, adding the exponents. 2y times 7 is 14y. Negative 1 times y squared is negative y squared, and then negative 1 times 7 is negative 7. We do want to put these in descending order of your exponents. So we want the y cubed first, the y squared second, the 14y, and then the minus 7. So you can see here that you have 3, 2, 1, and then your constant. And that's what you want to do, is make sure they go in descending order there. And they're not like terms, so that will be it. And so for all 4 of these, you could actually use your generic rectangles. Just be sure on C, you can only use your generic rectangle with 2 of them first and then the third one. So you might have to do 2 generic rectangles depending on how you're going to set that one up. Question 51. Consider the sequence 2, 8, 3y plus 5. Part A says find the value of y if the sequence is arithmetic, and then B wants you to find the value of y if the sequence is geometric. So I'm going to set this up as a table for A. And so we have our term number and then our term value. So at term 1, it is 2. At term 2, we're at 8. And then term 3 is 3y plus 5. So this one says if it's arithmetic, which means we are adding to get to the next term. So 2 plus 6 is 8. And then 8 plus 6 equals this 3y plus 5. So we'll just set it up. 8 plus 6 is supposed to equal 3y plus 5. And if we set that up, then we can solve for the y value if this is a arithmetic sequence. And it looks like we will get a y value of 3. So if you plug that 3 back in, it's 3 times 3 plus 5, which would be 14. So doesn't that make sense? If I take 8 plus 6, that would give me a value of 14. So on the arithmetic sequence, it would be y equals 3. On the geometric sequence, let's do the same thing. So we have n and t of n. We have 1, 2, 2, 8, and then 3 is 3y plus 5. So same thing, but now we have to multiply. So 2 times 4 is 8. 8 times 4 has to be 3y plus 5. So we'll do the same thing. 8 times 4 is supposed to equal 3y plus 5. So 32 is equal 3y plus 5. Subtract the 5. Divide by 3. And y equals 9. And once again, if we plug that in for the y value, you get 27 plus 5, which is 32. So if I'm going to take 8 times 4, I should be getting a value of 32. So it checks out that y should equal 9. Question 52. Copy and complete the diamond problems below. The pattern used in the diamond problems is shown at the right. It's the same as it always has been. So on the first part, part A here, we have 1/2. And this is your x value, and then the top part is x times y. So this is y. So what's 1/2 times y? That would give you 4. Well, if you multiply by 2, that's 8. So this would represent 8. 8 times 1/2 is 4. And once again, I did it algebraically, but you can do that in your head. That's not a problem. I'm just showing you where that number is coming from. And then now we can add those two. 8 plus 1/2 is 8.5, or 8.5 is fine as well. Or 17/2 if you want to do it that way. Part B gives you x and y. So on that one, we just need to take 0.3 and multiply by 0.2. And that'll give us a value of 0.06. And then also 0.3 plus 0.2. And that'll give you a value of 0.5. So those on part B was giving you the x and y, so you just had to add and multiply. Now on C, it's giving you the product. So this is x times y, and this is x plus y. Okay? So we're trying to find values that multiply to give you 11, but add to give you 12. So what are factors of 11? Well, it's prime, so it only has 2 factors, one in itself, 1 and 11. We also could look at -1 times -11. But which one of those pairs adds up to a positive 12? That would be the first one. So +1 and +11 multiply to give you 11 and add to give you 12. Alright, and on to the last one. We're given x, we don't know the y value, and we know the product is -4. Once again, you can do this in your head, or -3 plus y is -4, so therefore y is equal to -1. So -3 plus -1 is -4, then multiply -3 times -1 to get a +3. So there are the 4 diamond questions, given different values in different parts of the diamond for question 52.